For the first problem on the Chapter 3 review sheet, we want to try to rewrite f of x equals 1/8 times 4 to the 2 minus x in the form so it matches up with one of our multiple choices. So if we look at 1/8 and 4, we know that we can write both of those with a base of 2. So I'm going to write 1/8 as 2 to the negative third, and I'm going to write 4 as 2 squared. And then the 4 is still raised to the 2 minus x. And using the properties of exponents, I can distribute the 2. So I have 2 raised to the 4 minus 2x. And then I also know that if I am multiplying, I can add my exponents. So I have 2 to the 1 minus 2x. So if I look at all my choices, so far it doesn't match up with any of them. It's very close to C and it's very close to B. But what I could also do is take my exponent and factor out a negative. So I have positive 2x minus 1. And the negative exponent will flip my 2 to a 1/2. So I have 1/2 to the 2x minus 1. So my choice is A. For number 2, we want to rewrite the following expressions in exponential form. So we want to remember about base answer power. So for the first one, the base of my logarithm is going to become the base of my exponent, and the answer is going to become the power. So I'll have z equals 5 to the 12th. And since this will be on the non-calculator portion, you can leave your answer as 5 to the 12th. For B, I want to remember that whenever I have a natural logarithm, the base is e. So I'll have x equals e to the third. For part C, I'll have 8 equals b to the third. And for D, I'll have 16 equals e to the x. For number 3, we want to go backwards and rewrite the following exponential equations as logarithm. So also you want to remember about base answer power. So the base of the exponent is going to become the base of the logarithm. So I'll have log base 5, and then we write the answer next. So log base 5 of 125, and then the exponent becomes the answer. So the power becomes the answer. So for part B, I'll have log base x of 32 equals 5. For C, I'll have log base 25 of x equals 3/2. And for D, I'll have log base 12 of 1/12 equals x. For number 4, we want to evaluate the following logarithms without using a calculator. So for A, we have log base 8 of 8. So they're really asking us 8 to the what power equals 8. So my answer would be 1. For part B, we have 4 to the what power equals 2. And since we want to take 4 and shrink it down, we're going to need to root 4. We know that the square root of 4 equals 2, and when you raise anything to the 1/2, it is the same as square rooting. So our answer will be 1/2. For number 25, the question is 25 to the what power, I'm sorry, this is problem number C, 25 to the what power equals 1, and that would be to the 0 power. For number 5, we have 5 to the what power equals 1 over 125. So this answer would have to be negative since we are taking 5 and turning it into a fraction. And 5 to the third equals 125, so we would have to have 5 to the negative third to equal 1 over 125. For question E, we have log base 6 of 6 to the third. So the question is 6 to the what power equals 6 to the third. So the answer would be 3. For number F, we have 8 to the what power equals 32. In this case, you can't raise 8 to a power to get 32, because if you raise 8 to the second, you would get 64. So what we have to think about doing is shrinking it first. So we could raise 8 to the 1/3 first, because that is the same as cube rooting 8, which would give us 2. And if I took 2 and raised it to the 5th power, I would get 32. So what we did was we cubed root 8 and then raised it to the 5th power, which would be the same thing as raising 8 to the 5/3 to get 32. So our answer is 5/3. For G, the question is e to the what power, because remember we really have a base of e, equals e to the x squared plus 5. So it would just be x squared plus 5. Also, another thing that you can remember is that if ln and e are ever next to each other, they just cancel each other out. For h, we want to remember that whenever we see a logarithm with no base, he really has a base of 10. So the question is 10 to the what power equals 100,000. And we see that there are 5 zeros, so it would have to be to the 5th power. For number 5, we want to find the exact value of the expression without using a calculator. So we can see that there are multiple logs in this expression, and it may be easier to condense this to only one log. So we notice that we have log base 4, 8, plus log base 4, 16, and we can condense that through multiplication. So we would have 8 times 16, and we have minus log base 4 of 2, so 2 can go in the denominator of our fraction. So this would really equal, if I did some simplifying here, cross off the 2 with the 8, and I would get 4. So I have log base 4 of 4 times 16, which is 64. And this is asking us 4 to the what power equals 64, which would be 3. So the final answer is 3. For 16, we want to find the value of 2 times the natural log of e to the 8. And remember, whenever we have natural log and e next to each other, they cancel out. So really we have 2 times 8, which equals 16. For number 7, we want to use the change of base formula to rewrite log base 4 of 23, both as a common logarithm and as a natural logarithm. So the change of base formula says that we can rewrite this as the log of 23 divided by the log of 4. This is how you would put this logarithm in your calculator if you wanted to know what log base 4 of 23 is. We could also rewrite it as the natural log of 23 divided by the natural log of 4. We would get the same answer if we put both of those into the calculator. For number 8, we want to expand the logarithm and write it as a sum difference of multiple logarithms. So we notice that we have log base 3 of x divided by the 6th root of y. Whenever we see a root, we want to change it to a rational exponent. So we really have the log base 3 of x over y to the 1/6. And we see that these logarithms, that this is a logarithm of two terms that are being divided, and we can separate that using subtraction. So we have log base 3 of x minus log base 3 of y to the 1/6. And then the last step is we could take any exponents and move them to the front. So we'll want to move that 1/6 to the front. So we have log base 3 of x minus 1/6 log base 3 of y. So for b, we'll do the same thing. We'll first rewrite our square root of y as y to the 1/2. And then we have 3 terms in the numerator that are being multiplied together. So we want to make sure we separate those 3 terms. So we have log base A of 2 plus log base A of x cubed plus log base A of y to the 1/2. And we have 1 term in the denominator, so we have minus log base A of z to the 5th. And then our last step is to move any exponents to the front of the logarithm. So our final answer will be log base A of 2 plus 3 log base A of x plus 1/2 log base A of y minus 5 log base A of z. For number 9, we want to condense the logarithm. So the first step is to take any of the coefficients and move them to the exponents. So we'll have log base 4 of x plus 4 squared minus log base 4 of x plus 6 cubed plus 1/2, plus log base 4 of x to the 1/2. All right, and now we're ready to condense. So we have 2 positive logarithms, so those 2 terms will end up in the numerator. So we'll have log base 4 of x plus 4 squared times x to the 1/2. I'll just put that in front in the numerator. And the denominator will have x plus 6 to the 3rd. For number 10, it's the same thing. We want to write that as a condensed logarithm. So again, I'm going to move the coefficients to the exponents. So I have log base 7 of x to the 4th plus log base 7 of x minus 6 to the 3rd. And since it's addition, we're going to condense it using multiplication. So I have log base 7 of x to the 4th times x minus 6 cubed. So that looks like it is choice C.